In this video, we are going to find equations of lines that are parallel and perpendicular to given lines. We are going to focus on finding the equation of these lines using algebraic methods, but we will also be graphing these equations so we get a better understanding of what is happening. So let's look at number 1. In part A, we are asked to graph a line, y equals negative 2x minus 5. So to graph this line, we notice that it is in the form y equals mx plus b. So we will identify the slope and the y-intercept. So to plot, we start at the y-intercept, which is negative 5, and then we go down 2 and to the right 1. Because the rise is negative 2, the run is 1. And then we keep applying that slope to find other points. To find points on the left, this time I'm going to go up 2 and to the left 1. And then I drew a line through the points, drew an arrow at each end, and labeled the equation. Part B, we are then asked to find an equation of a line that is perpendicular to this line that we've just graphed, y equals negative 2x minus 5, and it passes through the point 1, 2, and we're asked to find this algebraically. So because we know this new line is perpendicular to this original line, we can use that to find the slope. As the lines are perpendicular, that means the slopes are negative reciprocal. So the new line will have the slope that is the negative of negative 1 over 2. So again, I flipped the fraction to get 1 over 2. The original fraction is negative. I take the negative of that negative, which makes this positive. So the new slope is then positive 1 over 2. We are also told that this line passes through the point 1, 2. So we have the slope of the line and one point that the line passes through. That is enough information to find the equation of the line. So to do this, we write y equals mx plus b. I will substitute in the value for m, which is 1/2. And then we will substitute in the point. So I will substitute in 1 for x and 2 for y. And now we will simplify and isolate for b. So here we're working with a fraction. So remember, when you are multiplying fractions, you do not need a common denominator. You multiply the numerators and denominator. Since the 1 does not have a denominator, I will write it over 1. So it becomes 1 over 2. And then I'm going to isolate for b by subtracting 1/2 from both sides. So the left side is 2 minus 1/2. And on the left side, I have 2 minus 1/2. When you're adding and subtracting fractions, you do need a common denominator. So this is 2 over 1 minus 1/2. So the first fraction, I'm going to change to 4 over 2. So they both have a denominator of 2. So that is 3 over 2. So the equation of the perpendicular line is y equals positive 1/2 x plus 3 over 2. So in part C, we are asked to graph this new line. It is in the form y equals mx plus b, so we can identify the slope and the y-intercept. So the slope is 1/2, and the y-intercept is 3 over 2. I'm going to write that as a decimal. It's just a little easier to plot a point when it is written as a decimal. So the y-intercept will be at 1.5. And now I need to rise 1 and run 2. So I'm going to go from 1.5 rising to 1 by 1 means I'm at 2.5. and then I go 2 to the right. And I will repeat that to get a few points. And I will also go down 1 and to the left 2. So just complete your line by drawing a straight line through all of the points with an arrow at the end and label your equation. And now we can see these two lines are perpendicular. They meet at a 90-degree angle. One line slopes up, so it has a positive slope, and the other line slopes down, it has a negative slope. In question 2, we are asked to determine the equation of a line that passes through point A and is parallel to the line x minus 2y plus 12 equals 0 algebraically. This is a similar question to the above question, but here the new line is parallel to the original line that's given. So we should highlight that. And in the previous question, it was perpendicular. So what we need to do is find the slope of this line that is given, and as the new line is parallel, it will have the same slope, and then we are given the point that it passes through. We are asked to find the equation algebraically, but I am going to graph the original line as well as the new line, just so we can see what is happening, but we actually do not need to draw the graphs at all when we're solving algebraically. So the first thing we will do is take the equation that is given and rearrange it to the slope-intercept form. So we will subtract x from both sides to get negative 2y plus 12 equals negative x, and then subtract 12 from both sides to get negative 2y equals negative x minus 12, and then finally divide everything by negative 2. So we get y equals 1/2 x plus 6. Be careful with your negative signs there. Both terms are negative divided by a negative. That's why they end up to both be positive. And the coefficient in front of the x is 1. So negative 1 divided by negative 2, we just leave it as positive 1/2. And negative 12 divided by negative 2 is positive 6. So we can identify the slope here is 1/2 and the y-intercept is 6. We are only interested in the slope because the lines are parallel. So I'm going to ignore the y-intercept. I don't need that information and just take the slope. So to find the new equation, we take the slope, the parallel slope is 1/2, and then the point that the new line goes through, negative 2, negative 5. And then we will just substitute into the equation y equals mx plus b. So first we will substitute in the slope, which is 1/2, and then we will substitute in the point. So again, we're working with a fraction. So when we're multiplying, let's think of those as both as being fractions. So we get negative 5 equals negative 2 over 2 plus b. I can simplify this to be negative 1. So negative 5 is equal to negative 1 plus b. And then I'm going to isolate for b by adding 1 to both sides. So we get negative 4 is equal to b. So the new equation is y equals 1/2 x minus 4. So let's graph both of these lines to see what they look like on the grid. So the first equation, y equals 1/2 x plus 6, has a y-intercept at 6, and then it has a slope of 1/2. So it looks like this. And then the second equation is y equals 1/2 x minus 4. So this time we start at negative 4 on the y-axis, but we use the same slope. So rise of 1, run of 2. So there we have both lines drawn on the same graph. The blue line is the equation that was originally given to us, and the green line is the one that we found. Here we are told that it's parallel to the blue line, which it is, you can see that. And we also were told that it goes through the points -2, -5, and you can check that on your graph, and it does. It's that point right there, -2, -5. In number 3, we are asked to find the equation of a line that is parallel to 3x minus 5y plus 12 equals 0, and it has the same y-intercept as another line, 2x minus 4y minus 8 equals 0. This question is more complex than number 2 because in number 2 we were given an equation and a point. Here we are given 2 equations. So the first equation, we want the slope because we know the new line is parallel to this equation. So we're interested in the slope. The second equation, we want the y-intercept. So we need to use this equation to identify its y-intercept. And once we know the y-intercept of this equation, we know the y-intercept of our equation. So I'm going to label the first equation 1 and the second equation 2. And I'm going to take equation 1 and I'm going to rearrange it to the form y equals mx plus b to find the slope. So just in the final step, be careful. -3 divided by -5 is left as positive 3 over 5, and -12 over -5 is positive 12 over 5. So now that it is in the form y equals mx plus b, we can identify the slope, which is 3 over 5, and the y-intercept, which is 12 over 5. Equation 1 is parallel to the line that we are trying to find. So we are going to take the slope from this equation, and we are not interested in the y-intercept from this equation. Next, we are going to take the second equation and find the y-intercept. There's 2 ways of doing this. We can rearrange this in the form y equals mx plus b and take the b value, or we can find the y-intercept by setting x is equal to 0. I'm going to do it the second way just because we just saw an example of rearranging, but it does not matter which way you do it. So we will take equation 2, and where we have x, we are going to substitute in 0. 2 times 0 is just equal to 0, so that first term goes away. So we are left with -4y minus 8 equals 0. And now this is a simple equation to solve for. So I'm going to add 8 to both sides. So I have -4y equals 8. And then I'm going to divide both sides by -4. So y is equal to -2. So the y-intercept is 0, -2. So now we know the slope of the equation and the b value, because we have the y-intercept. The slope came from the first equation, the b value came from the second equation. So we can say the equation of our new line is y equals 3 over 5x minus 2. So on the grid, I have graphed the 2 original equations that were given in the question. So equation 1 is in blue and equation 2 is in green. These are not parallel. They kind of look like they are, but you can see that the blue line is a little bit more steep than the green line. And now let's graph the equation that we found in the question, y equals 3 over 5x minus 2. So I will begin at minus 2, and I will apply the slope, so up 3 over 5. And that is the new equation that we found. So you can see that this new line, this red line, is parallel to the blue line, and it shares the same y-intercept as the green line. Again, you do not need to graph this if you are not asked, but it's just nice to visually see what is happening behind all of the algebra that we did to solve for this equation. In the next question, we will look at how to find equations of lines that are parallel or perpendicular to the axes. In question 4, we are looking specifically at the x-axis, but you can apply the same methods to the y-axis. There is not a lot of work that we can show to find these equations, but there is a lot of thinking behind finding these equations. So I have included the grids again. Here, these will be useful to helping us find these equations. If you are not given a grid to solve similar questions, you might want to sketch one. So let's look at number 4a. We are asked to draw a line that is parallel to the x-axis and it passes through the point 1, negative 3. We are then asked to find the equation of this line. So to do this, let's first start by identifying the axes. So our x-axis is here, the horizontal axis. We want to draw a line that's parallel to this axis, and it passes through the point 1, negative 3. So let's plot that point right there. So to draw a line that's parallel to the x-axis and passes through this point, we are also drawing a horizontal line just below the axis. So here we have a horizontal line, and horizontal lines will always cross the y-axis. This horizontal line crosses the y-axis at negative 3. So I'm just going to identify that negative 3. And we know that from the points. The y value in the point is negative 3. Any point on this line is negative 3. The x value changes depending how far to the left or to the right you are, but you are always 3 below the x-axis. So you went down the y-axis by 3. So the equation of this line is y equals negative 3. We have already seen that the equations of horizontal lines will always have the form y equals the value it crosses the y-axis at. So in 4a, we were parallel to the x-axis. And now let's look at 4b. We want to draw a line that is perpendicular to the x-axis, and it passes through the point 2, 5. So again, let's identify the x and y axes. So we have the horizontal axis is the x-axis. We want to draw a line that's perpendicular. So it's going to come up and down. It's going to be a vertical line to be perpendicular to the horizontal line. And it passes through the point 2, 5. So I'm going to plot that point. And then I'm going to draw the vertical line that passes through that point. So this new line is perpendicular to the x-axis, which means it's vertical. So to find the equation of a vertical line, we are interested in where it hits the x-axis. So here it hits the x-axis at 2. And we notice that every point on this line will have an x value of 2. The y value will change depending on how far above you are above the x-axis and how far below, but we are always 2 to the right. So the x value is always 2. So the equation of this vertical line is x equals 2. And just to refresh our memories, the slope for the horizontal line is 0 because the rise is 0. For a vertical line, the slope is undefined because the run is 0. So again, there's not a lot of work to be shown to find these equations, but there is quite a bit of thinking behind it. And so here having the graph is really useful.